atmosphere relationships. Friends, uh, this is the time for discussion. My request would be we have about 15 minutes. Kindly, if you have very specific question to each of the speakers, you can take up and the honorable speakers will try to answer that. If you have some long questions, you want more discussion, immediately we will have tea break. You can have that discussion with them at the tea break. So I will request if 2, 3 volunteers are here with their hand microphone to facilitate questioning, because we have a very big hall, so that will help. So we open the session for the discussion, please. There are 2 microphones, I think already. If somebody wants to ask any question, query, comment, please make use of. Okay, yes, please. Kindly name the speaker if to whom this question is.
François Tardieu, you may have seen me yesterday. So thanks a lot for the 3 speakers. I think it was extremely important to set this scene. The question I would ask the 3 of you. So I understand that this profoundly affects our vision of drought. The 3 things you have said: drought in terms of risk, water use efficiency, and drought as a flux of a very short time scales. Could you elaborate a little bit on the consequence of that for the audience? Does it impact the vision that any breeder or physiologist have of drought? Can you try to elaborate on that? Perhaps the 3 of you, if you...
Okay. So thanks for the question. I will try to make a start. I guess the answers will all be different from 3 of us to your question. The implication from my perspective for the breeder is that on the one hand, you also mentioned that yesterday in your talk, we have different types of droughts. And I try to extend that and by saying we have different types of environments. So we need to understand for which target environment we're actually developing a genotype that fits there. And I even try to sketch that broader and say it's not only the environment, it's also the management, and we know that. But even that is not enough. I think we should view that picture that's even broader in the context of the farming and the landscape system, because in this context, we also have to deal with other, let's say, societal demands on the farms, on the landscape, and the target for the genotypes that fit in these systems are determined by the demands that are posed on these systems. And that's more than environment, more than management. It's a broader context. That was my perspective that I tried to make. But then I'd like to pass on to...
So maybe my point was really this on the complexity of these problems is that we are addressing at that scale. And I don't really know if all of them, they matter finally for the whole. The thing is that when I look at the literature on root traits for drought tolerance, I found it pretty poor. And root depth, root density. I know some literature review. I think Vincent Vades wrote a very nice one on root hydraulics, and where actually it explains that root depth is not enough. There is more than that. So, for instance, root hairs as a trait for drought tolerance, I don't know if it has ever been explored. And but it's so. If you ask me, okay, what should you look at in the field? I don't know. I may tell you, okay, look at the peaks of transpiration. Looks at leaf temperature. The other thing is the time scale, and also what you call how wet is the soil or the soil moisture. So we get very big gradients in very small millimeters. So what is the average soil water potential that the plant is filling? This is, it's not easy. And, sorry. He's close, so I closed, but I know that I have to talk for everybody. And so often I see average, so also models that they run over days as a time scale of, well, I think your model they run at the time scale of, but what is the minimum scale? Okay, so what he says is that the time resolution can go down to minutes, and I think that it is relevant to go down to minutes. At least if I look at the plant, I know that at a single plant, if I look at it as a single day, and I compare these plants, this extreme, that would be the same. I would see no effect. But if I look at what happened in these 10, 20 minutes, they are totally different. And one plant may go to wilt and the other not, or you burn the leaves. And so including these fast processes, I think it's needed when we start averaging over time.
I guess I'd like to add that quite commonly what we call drought is confounded by soil drought, we might call it, is confounded by atmospheric drought. And I guess we'll see posters in here talks about that this week, that in conditions where the vapor pressure deficit is very large in the air and the temperature's warm, the high rate of transpiration can lead to breakdown in cohesion tension either in the soil, as we heard from Andrea, or I suspect within the hydraulics of the plant, including the leaf. And so I guess it's worthwhile for the breeder to, I mean, there's a lot of things to do, but the physiologist working with them or something needs to identify the kind of drought that is occurring. Is it a soil drought, or is it a atmospheric drought that's actually doing the damage? Because I know in Australia, when you have a very hot day, combination of the high temperature effects on photosynthesis and the high temperature effects on creating big BPD, it can really knock vegetation around. And just a few hours can knock vegetation around, and kill leaves. So it's not a drought in a sort of traditional sense of a lack of rain or anything. It's an atmospheric drought, and so maybe we need to extend the definition of drought. And I know that Francois is quite interested in that.
Yes, that's the.
Karambot Siddiq from University of Western Australia. My question is to Professor Graham Farquhar. You mentioned about climate change and variability, and you're saying that the variability is something which is more of concern than climate change because of the CO2 and other effects and so on. So my question, maybe I haven't got it clear, whether the variability has increased during the last 50 years as a result of high CO2 or temperature difference.
I guess the question would be variability in what? Obviously, we keep breaking records in terms of temperature. So if you call that variability, then the temperature variability in that sense, the records are being broken all the time because the general level of temperature is going up. But if you mean variability in terms of rainfall or evaporation or drought, well, no, I think the data showed that variability over the last 70 years in precipitation and drought, in precipitation variability has gone down slightly. In drought, it stayed about the same, averaged over the globe. Yeah, that's the problem. I mean, and averaged over the globe doesn't mean that everybody got their equal fair share. They didn't.
Could be a question of resolution here. So if you have a finer resolution, look at the smaller areas, then I don't know whether we have data about that, but that could be a different answer then. And that's what farmers usually experience in smaller areas. So they see a larger. That's also what they report, that they see a higher frequency in the droughts. That may average out over larger areas.
Just like to comment on Prank's comment. I think it's a good point he made about Frank made a good comment about the spatial scale, because the data that we describe in terms of drought or the data for rainfall depends on the scale at which the things are measured. And even in Australia, which is a fairly advanced country in some senses, there are huge distances between meteorological stations. I know that's also true in parts of Africa. So there's no way that you can actually you can't interpolate with without a lot of risk. And so in many parts of the world, these data are very large scale, and we'll miss out on the fine grain problems that Frank was referring to.
I think if you go and specifically look at some specific locations, take maybe Central Africa or Eastern Africa, southwest of Western Australia, and then look at the data and see whether the frequency of drought, for example, in southwest of Western Australia, we used to get to 1 in 5 years, or maybe 1 in 6 years. But that frequency over the last 30, 40 years has increased. We are seeing quite significant variation in rainfall and temperature. As a result, the farmers are facing the drought.
Perhaps one comment on this, that I guess we share the observation that there's a scale issue when it comes to drought. But there's also a scale issue when it comes to breeding, because you may observe increasing frequency of droughts in smaller areas. And if you look at larger areas, the average out is not a problem. But if you look at breeding, breeders are also interested to breed for larger areas. They're not so interested to breed for smaller areas where there is no market, no big market. So there is a value also in aggregating drought responses or frequency of drought. So that these two sides are, I think, should not be ignored as well in this discussion.
Okay, I think we can take one question more. We have, yes, please, lady.
Hi, Amelia Henry from Erie. My question is for Andrea Carminati. I was curious to know if you have any thoughts about particular crops or systems where this gap between the root and soil that occurs when soil dries is more or less of a problem. Are there some crops that have more mucilage in general, or?
Okay, I use this. No, actually, I don't really have an answer for this question. I think we didn't really look at, we just started to look at how this mucilage, what it is, how it works, how it's exuded. So I don't think, at least me personally, I don't know many data about which pieces they produce more. I think that, so what I know is that, for what I remember, is cereals they produce more than legumes, but this is based on a few types. So I know example of maize producing more than lupins. These were some of the plants that they were tested, but I don't really know much about that. So I'm looking mainly at now what mucilage is doing in a sandy or in a loamy or in a clay soil, because it's very different. That's also play a different role. But I don't know it. Maybe then.
Graham will supplement, yes.
Yeah. Comment on that. I'd like to draw your attention to the fact that in soil with a matrix potential of a megapascal, water is restricted to interstices with a radius of curvature of about 1/10 of a micron or something like that. I can't remember the exact figure. So my question for Andrea is, how the hell do you get even root hairs with mucilage? into interstices that are about 1/10 of a micron, when these things are about 10 times, way bigger. And is there a role for vapor transfer?
Yes. So vapor transport, we neglect it often, and you think we do wrong, and you're right. But so at that potential, you have a lot of, you start to have water films, and they play probably a bigger role than the capillary fluxes. So that's what you look at, typically this curvature. I think at that scale, especially in soils, when you start to have clay, we talk more about film flow over particles.
I think we don't want that you are delayed for your coffee or tea. Let me thank all the three speakers for excellent presentations. Friends, before we